Hi, everybody. Okay, so then in order to use what you just learned about quadratic functions, I I want you to go and graph a quadratic equation in general. Now, a quadratic equation has this general form: ax squared plus bxy plus c squared plus dx plus ey plus f equals 0, where at least one of a, b, or c is just not 0. Otherwise, it's not called quadratic. In that case, it's just linear. The graphs of these equations are all called conic sections. That's something you would have learned back in pre-calc, probably in high school. You might even saw it in one of our college algebra pre-calc classes. The most important non-degenerate conic sections, those are the ones that are not like lines or points or intersections of two lines, are the parabola, the ellipse, the hyperbola, and the circle. I'm going to show you how to graph them. Now, this next little portion of the video is review for a lot of you probably. If you have the basic idea of conic sections down, you don't need to watch this next part and skip to the next video where I show you how to graph general quadratics where there's a cross term. So now we're going to handle ones where there are no cross terms. So there's standard forms. The graph of an ellipse that's in standard position is just one that can be written in one of the following standard forms. I've given you three different equations. So that's x squared over a squared plus y squared over b squared equals 1, where a and b are positive. So in the first graph, a is more than b. The second graph, b is more than a. And the third graph, that's a circle. That's where a and b are the same. The graph of a hyperbola in standard position, if it can be written in one of the standard forms. And that is x squared over a squared minus y squared over b squared equals 1, or y squared over b squared minus x squared over a squared equals 1. And again, where a and b are positive. Notice that in the first graph, it does not intersect the y-axis. And the second graph, it does not intersect the x-axis. Then you have the parabola. It has 4 different versions. It's y equals a times x squared, y equals a times x squared, and that's if a is positive or negative, it opens up or downwards. You have x equals a times y squared, and it can open either to the right or to the left, again, depending upon whether a is positive or negative. So a graph of a parabola in standard position, if it can be written in one of those 4 equation forms. So then if you have a graph, you have an equation that doesn't have a cross term, you can pretty much be guaranteed to write the equation, the quadratic equation, in one of those standard forms. So I'm going to do that right now. This first equation, 4x squared plus 9y squared equals 36, that's an ellipse. It's an ellipse because if you just divide both sides by 36, you would get x squared over 9 plus y squared over 4, and that equals 1. And that's actually the equation of an ellipse in standard form. The second graph, the second equation is actually a hyperbola. It's just written a funny way. Notice that you can subtract the squared terms to get 1 equals 9y squared minus 4x squared. And then weirdly, you can write that as 1 equals y squared over 1/9 minus x squared over 1/4. Remember, it's just numbers. A and b are just numbers. They have to be positive. So that is the equation in standard form. The graph of that, therefore, is a hyperbola. It's a hyperbola that does not cross the x-axis. And the last one, that's obviously a parabola. Just solve for y. You get y equals, it will be 4/9 x squared. So then that's the graph of a parabola. In fact, it opens upwards. Now, thing is, though, is that many times the equation has extra terms that are not yet taken into account of in the little tricks that I showed you. So what you can do is you can change the axis system, giving points new names, not moving points, but giving points new names, so that the origin is in a new place, so that the equation has a new form, so that it's the standard form for some conic section in standard position. So then I'll do that here. Again, this is a trick I'm sure you've seen before if you've studied conic sections before. Notice you can take this equation, you can group the x terms together, you can group the y terms together, and move the constant 9 to the other side by subtraction. I'll complete the square on the first term, take -6, have it, and then square it. I get 9. And I'll add 9 on both sides. to balance things out. Here, I'll factor out 2 first to get y squared plus 4y. But I can write the first expression as x minus 3 squared. This will then be 2 times. I can complete the square on the inside to get y squared plus 4y. I'll take the 4, I'll have it. That will then be 2, and I'll square it, I'll put 4. I'll add 4 here. When I added 4, I actually added to the left-hand side 2 times 4 because the 2 is multiplied to the 4 inside that parenthesis. So I added 8 on the left-hand side. So I have to add 8 on the right-hand side also. That means that I have x minus 3 squared plus 2 times y plus 2 squared equals, well, that's a fancy way of saying 1, isn't it? So that equation can be written as x minus 3 squared plus y plus 2 quantity squared over a half, and that equals 1. And that's the standard form of an ellipse. So then it's an ellipse. It's just been shifted. You can then just say that I'll replace x minus 3 with x prime and y plus 2 with y prime to get a new axis. And all that does is take the axes and move them horizontally and vertically. And you get the new equation, which is x prime squared plus y prime squared over a half, and that equals 1. And that is the equation of an ellipse. Okay, good. So then I believe then you have the basics of this. The next video, we then apply the ideas.